Good afternoon, class. What we're going to be talking about today is diving, basic physiologies of diving. We're going to see some of the effects that this has on our body and some of the equipment that we need to use to be able to go down diving. So let's start off. We live in an atmosphere of 1 atmosphere of pressure in all our daily lives. This is equal to 14.7 psi and 33 feet. It's equal to 33, going down underwater to 33 feet. So for us to go diving, we need a regulator. This attaches to a tank, a cylinder, which has got air in it. The air is 79% nitrogen, 21% oxygen. And the regulator and the cylinder are attached to each other, which is attached to a BCD, which is a buoyancy compensator device. This allows us to maintain our depth underwater by increasing and decreasing the air within this waist jacket that fits around us. We have fins on, this propels us underwater, and then we have a mask which allows us to see. So, we're ready to go diving. Imagine that you've just blown up a balloon, and you've got this in your hand, you jump in the water, and we're comparing this balloon to our lungs. We jump in the water, we go down 33 feet, we use our buoyancy compensator device by adding or decreasing the air to keep that 33 feet, but we look at the balloon. Now, what happened to the balloon compared to the surface is it's actually half the size. The reason it's half the size is we've just doubled the pressure on that balloon in all areas, because we have to include the 1 atmosphere on the surface plus the 1 atmosphere of pressure that we've just went under 33 feet. Now 1 atmosphere is equal to 14.7 psi. We doubled that, so it's 29.4 psi. So we're comparing the balloon to our lungs. Now, it doesn't affect the air in the cylinder because that's in a rigid cylinder. It can't affect that air within there, but it affects our air in our lungs. So if it's half the size of the balloon, it's also half the size of our lungs. And to keep our lungs the same size at 33 feet, we've actually got to breathe double the amount of air at 33 feet to keep our lungs the same size. So that's what the regulator allows us to do, basically. That allows us to regulate the amount of air that we're breathing to keep our lungs the same size underwater. We just breathe normally all the time. We don't hold our breath. We just breathe normally all the time, in and out, long, deep breaths. Now, as I was mentioned, air is made up of 79% nitrogen, 21% oxygen. And the thing is that our body loves nitrogen. Our body gets the nitrogen gets absorbed into our body through the skin, into the blood, and also when we're breathing, and it gets attached to our fatty tissues, our muscles, and the body just absorbs it as quick as it can. So this is okay underwater. We don't feel any ill effects from it. But where the problem arises is when we want to come back up. We've already swam around for about an hour underwater. We've looked at all the pretty fish under there, the parrotfish, the starfish, sea urchins, and maybe seahorses if we're lucky. So we want to come up now, and we have to do that at a very regulated rate, because what we don't want to happen is we don't want all this air that's been absorbed in our bodies expanding. As I say, as we breathe normally, we don't hold our breaths. So we start slowly coming up. Probably a rule of thumb is you travel at the smallest bubble that you're breathing out from your regulator, if you don't have any other equipment to do so, to tell you how fast you're coming up. That's a good rule of thumb. So just imagine we just absorbed all this nitrogen. The thing is, our body loves it, but it hates to get rid of it. It's actually really slow coming out of our body. So as we come up, if we come up too fast, what happens is this nitrogen expands. Then the bubbles get bigger within our blood. And then what happens is they get stuck in areas like our elbows, our shoulders, or anywhere there's a joint. And then it becomes, actually, as you come closer up to the surface, they expand more, they create pressure points on our joints, and it causes pain. Now this is what we call the bends, and that's why we call it the bends, is because what it does is it'll actually bend you over in pain until you get it sorted out. And basically the best way to sort it out is they're going to decompression change you, resubmerge you under pressure, and then allow this to slowly come out your bodies at a regulated rate. Now, as you're taught diving, you will be taught to come up at a slow rate, so this is never a problem. And it's actually a very enjoyable sport, and it's a wondrous thing to see. 70% of the Earth's surface is covered in water, and we've only explored a small part of it, even though we've been to space. We've not explored all of our surface underwater, so diving is a good way for us to be able to do that. You shouldn't be scared of the bends. It's not something that happens to many individuals, but it's just something you should be aware about when you go diving. Just like any sport, there's hazards with any sport. So I hope this was it was pretty brief. We could go on a long time about our diving and the physiology and get into it, but it's just the basics. And I hope you enjoyed the speech. Take care. Thanks.